Hello everybody, it's Miss Barrett here and welcome to Fractions Lesson 2. Okay, I will get this right, I absolutely promise. So what are we doing today? Okay, we are learning to simplify fractions. This is our second lesson, and what am I looking for? I want you to be able to identify the numerator, identify the denominator, find a common factor, and the vocabulary, the keywords that we will be using: fraction, numerator, denominator, simplify, factor, common factor, and equivalent, meaning equal value. All right, so we've got some information in our Discover. Let's have a little look and see what's. Okay, we've got some people, children, it looks like, and adults. We've got a roller coaster. Some are in the cars waiting to go on the ride. Some are waiting to go in to sit down. Yeah, so we've got a roller coaster, are groups of people. Some are grown-ups, some are children. The question, what fraction of the people are children? And it's, oh yes, simplify your answer. So let's have a look at this. Fraction of the people are children. Well, potentially it's a little bit difficult to identify who are the children. So just to make things a bit easier, okay, we've got an adult here, an adult here, an adult here, 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 and here. Righto, so it looks to me that there are 6 adults all together. So let's find a total. We've got 2, 4, 6, 8 people standing. 10, 12, 14, 16, 18. So it looks like there are 18 people altogether. And it looks like there are 6 adults. So to me, 12. 12 of the people are children. So what's that as a fraction? 12 children out of 18 people. So of course, the fraction will be 12/18. Yeah, I'm good with that. It talks about simplifying. So we need to identify the factors of 12. And I know that 1, 2, 3, 4, 6, and 12 all are divisible into 12. So therefore are factors. But to simplify, we need to find a common factor. And I know that the factors of 18 are 1, 2, 3, 6, 9, and 18. And I'm going to go for 6. I'm going to talk about 2 and 3 as common factors very shortly. So to simplify, we divide the numerator and the denominator by the common factor. And in this case, I've chosen the highest common factor. And it will be 6 because I know it goes into both 12 and 18. So to simplify, 12/18 will be 2/3 because we divide 12 by 6 and 18 by 6, 6 being the common factor, to simplify 12/18 to 2/3. So therefore, final answer, 2/3 of the people are children. So this chap here has done it a little bit of a different way. And he says he knew that 12 and 18 can both be divided by 2. And they can also be divided by 3. So therefore, there are other common factors that can simplify 12/18. So the first, let's go with common factor of 2. If we divide 12, the numerator, by 2, it gives us 6. If we divide 18 by 2, the denominator, it gives us 9. So 12/18 is equivalent to 6/9. But simplifying, let's see if we can go lower than that. And this is where the other common factor of 3 comes into play. So divide the numerator and denominator by 3 again, and it reduces 6/9 further, simplifies 6/9 this time to 2/3. Now that was the original answer when we had a common factor of 6. So therefore, 2/3 of the people are children. Yeah, I'm good with that. All right. So what about the capacity of the roller coaster carriages? Now, when I talk about capacity, I mean how full are the carriages? And if we take a quick look at the information here, well, we can see 2 carriages. We can see that one has got 1, 2, 3, 4 children and 2 adults. So it looks like the full capacity for each carriage is 6. So to me, 6 out of 6 people are in that carriage, okay, regardless of adult or children. In this carriage, however, it looks like there are 2 spaces. So there are 1, 2, 3, 4 out of a possible 6 spaces. So in terms of the maths, let's have a look. how many roller coaster carriages are full? And it asks you to simplify your answer. Well, let's interpret this from the point of view of a fraction. Here we go. The question again, roller coaster carriages. How many of them are full? And simplify your answer. Well, let's take this first carriage, like I kind of was saying. Yeah, it's made up of 2 adults and 4 children, but I guess that's irrelevant because it doesn't matter how many people are in there. That's one full carriage. One whole, represented here on the diagram. Yeah, good with that. What about this carriage here? Well, that's partly full, and it's made up of 2 adults and 2 children. Again, it doesn't matter what the combination of people are, but the point being it's not full. And there are 4 out of possible 6 places because 2 empty spaces. So as a fraction, that looks like 4 out of 6 seats are full. Represented here, 4 represented by the yellow, 6 represented by 6 equal parts, each representing a sixth. Yeah. With that in mind, it asks, if you just cast your mind back, how would you simplify 1 whole and 4 sixths? Well, I need to find a common factor, a factor that goes into 4 and 6. Well, I know that 4 is divisible by 2. I know 6 is also divisible by 2. So a common factor of 2 would then simplify 1 and 4 sixths into 1 and 2/3. 1 whole carriage is full and 2/3 of the next carriage is full. 1 and 4 sixths simplifies to 1 and 2/3. In answer to the question, yeah, 1 and 2/3 of the roller coaster carriages are full. All right, it's your turn to think. Remember to read everything. I'll read the question and I'll give you a moment or two to have a little look and see if you can answer the questions, and then we'll go through the answers. Olivia wants to go on the ghost train. 3 of the carriages are full. In the remaining carriage, 8 out of 10 seats are taken. So we've got some calculations here, obviously to populate with numerators and denominators. We've been given something to simplify, and we've got some representations here as diagrams. Pause the video, see if you can come up with some answers. Okay, so I hope you've had a little go at Olivia's problem here. She wants to go on the ghost train. 3 of the carriages are full, and in the remaining carriage, 8 out of 10 seats are taken. So we've got simplifying 3 and 8/10. So it's kind of given you the answer, but represented, let's have a look and see what that means as this diagram here shows. Okay, according to this, 1 full carriage, 10 out of 10 people. So it's full. 10 people are sitting in that carriage. So that represents 1 whole. 2 wholes, so another 10 out of 10 people. And a 3rd carriage. So we've got 1, 2, 3 full carriages, 3 lots of 10/10ths. Here, 1, 2, 3. But in the 4th carriage, it looks like each of the tenths here, so 10 equal parts, of which 8 have been taken. So 8 out of the 10 seats are taken. So as a fraction, that's represented by 8/10. Part of the carriage is full. Right, I can see where the 3 and 8/10 comes from. 1, 2, 3 whole carriages and 8/10 of a carriage. But like everything, we need to simplify. So this next little section here is telling you to use a common factor of 2, which of course 8/10 would then simplify to 4/5. That's represented here on this diagram. Let's have a look. We've got our part full carriage here. Look, 8/10 here, simplified to 4/5. We've got 1, 2, 3, 4 out of 5 equal parts here, representing 2 seats, 2 seats, 2 seats, 2 seats. 8 out of a possible 10 if it were here, but as we've simplified, 4/5. So I'm cool with that. So what about the wholes? Well, the wholes stay. 1 full carriage, 2 full carriage. So we've got 3 full carriages and 4/5. I see. So in answer to the original question, to simplify 3 and 8/10, here, the 3 full carriages remain the same. because you've still got the same capacity. Nobody's left. All right. And where we used to have 8/10, the equal values simplified would be 4/5. So it looks like simplifying 3 8/10 is the same or equivalent to 3 4/5. I hope you got on all right with that. How about this one? Okay, I'll read it to you, then pause, and then we'll go through some answers. So this time Olivia gets off the train after her ride and she counts that 25 people are waiting. Each carriage has 10 seats. The question being, how many carriages will be full? Simplify your answer. Okay. So Olivia gets off the train. She counts 25 people. Each carriage has 10 seats. So what I asked you to consider was how many carriages will be full and to simplify your answer. So our diagram here, let's have a look and see what that shows. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got 10 equal parts. That's got to represent one carriage. So as each of those parts seems to be shaded, I'd say that's one full carriage or 10/10. So we've got one whole one. And it looks to me like we have an equal amount here, or we have another full carriage. Let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, another full carriage, 10/10. So in total, 2 full carriages of people. However, in the third carriage, it looks like we've got 1, 2, 3, 4, 5. Count that again. 1, 2, 3, 4, 5. 5 out of a possible 6, 7, 8, 9, 10. Okay, so 5 out of 10 seats are taken in the third carriage. And that would be written as a fraction as 5/10. So we have here 2 full carriages and 5/10. So 2 and 5/10. Okay, so what's this down here? Oh, Olivia's written her problem here as a fraction that's top heavy. In other words, an improper fraction showing 25th tenths. And what we've been able to do is to convert that into a proper fraction, a mixed number, where it shows the full number of wholes, the carriages that are completely full, and the fraction. So in this space here, we've got 1, 2 full carriages. So 25th tenths, 25/10, I beg your pardon, is the same as 2 whole carriages, and then 5/10. But like always, it's asking us to simplify further. So 2 and 5/10 simplified, while the 2 whole remains the same, and you can simplify 5/10 by a common factor of 5, which would then simplify 5/10 to 1/2. So it looks like to me that the final answer, the carriages that will be full, there are 2.5. Yeah. Okay, lesson 2. It's your turn to have a go at working independently. On the next slide are the worksheets from your books at school. Here they are. Have a read through. And in a moment, you might want to pause the video so that you can see the questions. I would write your answers in your yellow homework books. And then I very much look forward to receiving your photographs of your finished pieces of work. Now, if you fancy a deepening challenge, I'm just going to flip to the next page. There are 2 deepening challenges that you might want to consider. Question 2 says children trying to fully simplify a mixed number here. 16 and 8/24. And question 3 is asking which is bigger, 288 160ths or 9/5. Now, I would say both of these challenges lend themselves to a PEE. Make a point, find some evidence, and then explain your answer. I'll just throw it out there. So it'd be great to see if you fancy a deepening challenge. Why don't you? Don't tell anyone. Have a P. Anyway, well done. Lesson 2 over. Go back and have a look at the worksheets for today, and I can't wait to receive your work. Okay, people, thanks very much for your attention. You know where I am. Drop me a message on Dojo if you need a hand. Take care. See you soon.